Πρώτος ομιλητής είναι ο κύριος Μάρκο Gioanola, ο οποίος είναι Senior Consulting Engineer των Arbor Networks και θα μας μιλήσει για things others can see, the need for global and local intelligence in the fight against advanced threats, real-world cases and experiences. Please, the floor is yours.
Hello. Hi. Okay. So thank you. My name is Marco Gioanola. I'm a consulting engineer for Arbor Networks. I am based in Italy and I take care of Greece as well, together with our partners AdaptIT. We have our booth outside. Arbor Networks is well known for being the leader in DDoS mitigation in service provider and enterprise markets. Today I will talk to you about DDoS mitigation and also advanced threats, which is another field of research that we do. I will not try to talk much about products. I will not try to sell you stuff, hopefully. I will try to point out some interesting information, hopefully, and also point out some interesting questions to you to make you think about how you can plan your security inside your company. You heard all day information about advanced threats, about security, etc. I want to add a little more information, a little more point of views to make you think a little more. I've added these images here to focus on the fact that I would like to show you to see things from different perspectives. I think that in security we have this challenge of the fact that we need to look at the very microscopic thing, at the very small things, and at the very large things, at the very infrastructure level things. So you have to have a very large set of weapons that you need to use with regard to IT security. I want to start with a very well-known example that you probably everybody has heard of. I do not need to tell you the story again about Snowden, who exposed the documents from NSA, etc., etc. What I want to highlight is a few interesting lessons that we can learn from this case. When some journalists did some investigation about the Snowden case, NSA investigation, it turned out that NSA, the National Security Agency in the US, admitted that they say, well, it was very easy for Snowden to expose, to steal these documents. He didn't do anything particularly smart, or he wasn't a very strong hacker. He copied the files because that was his job. He had the permissions to do that. He just copied the files. Okay? So this teaches a very important lesson. I mean, this is the most important security company in the world, security agency in the world, and somebody can, you know, an employee can just take, I don't know, 10 gigabytes of documents and FTP those documents somewhere, and everybody sees it and say, well, okay, it's his job. There's no problem, nothing strange. So there are some inconvenient questions I want to ask you, and this case brings to us. So how do you detect in your company if an employee, an internal employee, copies all the documents from your file server to his PC at home, because maybe he has a VPN? So he just, maybe he's in the office, he opens an FTP connection towards somewhere, he copies everything. Nothing strange, because the firewall will let the FTP pass, the IPS will not see anything because it's just FTP, okay? So, or maybe he copies everything on a USB key from the file server to his PC on work, and then he takes the USB key home. Anybody notice? No, because it's internal network traffic. So that's a very strong question. So Even worse, how do you detect if privileged users are abusing of their privileges or even of encrypted channels? Your system administrator, they have SSH access, they have VPN access, and it's normal that they access those servers by using those encrypted channels. But do you notice if your system administrator at 2 a.m. at night is copying 10 gigabytes of stuff via SSH? Probably not, because you don't have a firewall everywhere, you don't have an IPS everywhere, you cannot look inside SSH. Okay, so it's very difficult. Does your firewall know what time it is? I don't think he knows, because he cannot tell if this is strange at 2 a.m. or this is strange at 2 p.m. This is strange on Friday, this is normal on Saturday. This is another thing. It's normal that people access the mail server during office hours. It's not normal that they do it on Saturday and Sunday. Okay, so these are something that we should look for in security devices. So we have some inconvenient questions, and we have also some inconvenient answers, unfortunately. And how do you detect that your company has been compromised? And the inconvenient answer is that sometimes you just don't. Somebody will tell you after 6 months, well, you know, I found your price list on the internet. Well, how did that happen? And you realize only after that. So how do you investigate in those kinds of things? So traditional security solutions, firewall, IPS, antivirus, anti-malware, are necessary. You have to have them, but they do not scale. And in my opinion, in a lot of cases, they do not even work, because they are designed to do something else. They are designed to detect known bad things. If there is something strange, they don't know. Antivirus, endpoint agents. Have you tried deploying user endpoint agents on all your PCs if you have a network with 1,000 PCs or servers? It's a nightmare. I mean, probably you have to do it, but from a management point of view, it's a nightmare, and it doesn't cover all the cases. So what we have learned, and our answer is that the key to integrate and to complement all these traditional security devices is what we call behavioral anomaly. So we need something that can learn the normal levels of traffic and the normal behaviors in the network to understand that that particular amount of SSH traffic on Saturday afternoon is strange. I want to raise an alert, and I want to check what happened. Okay. Some more inconvenient questions. Okay. Sometimes you don't realize you cannot detect that you have been compromised, because you cannot have detection everywhere. You just realized after the fact has happened. And this is why we had sessions about incident response and stuff like that. So what is your incident response strategy? Okay? Does your company have an incident response process? Do you know who is in charge when you discover that documents in your company have been stolen? Who do you call? Ghostbusters. Who do you go to? So you have to know these kind of things. How do you trace back what happened? Okay, they stole my document. How? When? Why? When did they do it? Okay, maybe they did it 6 months ago, and now you find it on the internet, or maybe your competitor has your project or your press list. So what do you need to do to investigate these kind of things? One thing I want to make you think about is the definition of APT. Probably today we talked a lot, you heard a lot about advanced persistent threat. I want to stress the fact that they are advanced, where advanced means smart, which is smarter than a signature, smarter than the stateful inspection, smarter than this well-known pattern. These are anomalies abusing legitimate protocols. And they are persistent, which means they are long-lasting. So real-time detection is not enough. It's not like I can detect, wow, now there's an attack, I can block it. Well, in some cases I can do it, but if somebody infected a host 6 months ago, and after 1 month that host copied some files on the server, and after 1 month that particular server stole the password of another user, this is a persistent threat. How do you detect this kind of long threat? And that's the inconvenient answer. You need a time machine. You need to go back to be able to go back in time and see what happened 6 months ago, and see what that particular IP or what that particular user might have done. So I did some. So how do you implement a time machine in information technology? You implement it with storing and with listening, with sniffing all your traffic, all the data. You have to copy it somewhere. Okay. I did some math, and if you copy a 100 megabit network traffic, packet by packet, for 6 months, you have 200 terabytes of packet capture. So this is your time machine. The time machine is 200 terabytes of traffic to inspect 6 months of data. So if you want to have this time machine, and well, probably you should have if your company is dealing with very critical data, you need a packet capture infrastructure. You cannot just go on every switch, on every PC, and connect a cable and take traffic. There are specific packet capture infrastructure, network taps, etc., that you can use. You need storage to store all this data. And you need the actual time machine. You need something. You need to be able to apply what you know today to what happened last year, 6 months ago, 1 month ago. Today we heard a lot about zero-day threat. Zero-day means it's something that was unknown until now, and probably somebody was exploiting that problem, that security problem for months. So, but we discover it now. So we need our time machine to be able to look in the past and see, okay, well, now I know about this vulnerability, and now I can see that 6 months ago this vulnerability was exploited in my network. And of course, you need processing power and intelligence. So processing power, I don't know if you know this one, PDP-11, maybe the oldest of you, and you need the most important type of intelligence, so human intelligence, okay? So you need brain, you need somebody, you need a security engineer looking at this security event, somebody who has the right skills, the right education to look at this particular security event. So if we move away from the very microscopic events and we take a look from the sky to the macroscopic, to the other end of the range of attacks, of security attacks, what we have distributed denial of service. Okay, probably everybody knows what is a distributed denial of service. It's a large attack targeting resources, either network resources or computational resources or service resources. This nice visualization is a project by Google, Google Ideas. You can find it on Digital Attack Map. And this is a beautiful visualization of real-time DDoS attacks built on top of Arbor Networks data. And we provide the background data to Google to do this very, very nice visualization. I have a use case that happened last year in Italy that I want to talk to you about, because it really shows all the steps in DDoS mitigation and all the challenges that customers find. So we had this online gaming community. It's a free card game on the internet. It was quite large, 3 million registered users, 30,000 players online in peak time. Okay, they have a free platform. You can pay a premium to have some additional services. They were attacked repeatedly at peak time. So the attackers knew that at Saturday night, 8 p.m., it was the time when people went online playing cards on their website. They did a very short attack, 5 minutes, all the sessions went down, people got disconnected, they lost their points, etc., etc. So people were starting to move to the competition. So they dropped from 3 million subscribers to 2 million subscribers. They tried firewalls, they tried IPSs, everything was crashing because the attacks were targeting the state tables of these devices. So they finally contacted us. Our reseller installed the trial, and with a default configuration, we managed to, of a dedicated DDoS mitigation device, we managed to get a relatively good protection and some analysis. We saw that, well, the attack was a DNS request flood. So, well, quite easy. We blocked DNS, we blocked these particular queries. The attackers escalated. They say, okay, I want to generate more volume. I will start a huge flood on protocol 3. Do you need protocol number 3? No, let's block it. One thing that we realized, and that you see in DDoS attacks, is that when attackers realize they are mitigated, they try to escalate and to create more bandwidth. The problem is that the customer was behind a 100 megabit connection, which was seen as premium, okay, for them, but that was congested in 2-3 minutes. You can see that. So what's the answer to that? The answer is that you have to have an integrated DDoS mitigation solution, something that has something on premises that can give you real-time, immediate mitigation up to the amount of bandwidth that you have available. Once you have a volumetric attack, you have to have something which we call cloud signaling to talk to your ISP, to OTE, to Fortinet, to whoever provides you that service, so that they can redirect the traffic in their cloud, send you only a manageable amount of traffic, and so that you can continue to mitigate on premise. And that we believe is key in DDoS mitigation strategy, a multi-layer infrastructure that can protect you from the application layer attacks that we saw and from the volumetric attacks that we know exist. The latest trend, I just want to show you some numbers, and again, this is numbers from Arbor Networks, from our research. This is the size of NTP traffic since December last year, when the vulnerability against NTP servers was discovered, where you can use NTP for large amplification attacks. So the small blue line was the normal, and now we have peaks of 800 gigabit per second of global NTP traffic, which, you know, compared to the normal, is still incredible. Well, I will go, and I'm done. If this is very, very fast. I built this slide just to try and give you a visualization of the size of the attack. Okay, the size of the problem, of the DDoS problem. Let's take an ADSL line. I don't know, 4 megabits, 20 megabits, something like that. Maybe a small business, they have 20 megabits, 50 megabits, 100 megabit connectivity, something like that. A medium business may have 150, something like that. Maybe somebody has 1 gigabit of connectivity. The median attack size in last year was almost 1.3 gigabit per second. This is Arbor network research that you can find on our website. So it means that half of the attacks were less than 1.3 gigabit. So let's say somehow manageable locally. The average size of attack was more than 2.6 gigabit per second. And this is when you need to ask cooperation from your ISP. Your ISP's network is based on 10 gigabit per second links, so apparently it's quite larger than that. They have multiple 10 gigabit links. The largest attack registered in 2012 was 100 gigabit, okay? And this is real verified data. The largest attack in 2013, from the survey we asked customers, was 191 gigabit per second. The spam house attack in March last year, and the size, let's say the average size of the NTP-based attacks we see now is 300 gigabit. So this is the potential size of DDoS attacks today. So you see your medium business, small business connectivity where it ended up. So my final point is, you have to stop the attacks in the right place. Microscopic things, you have to have a microscope to see every tiny detail. You have to have something to, you have to have the time machine to replay what happened in the past, to do analysis, incident response. You need to have behavior analysis to discover that guy in the crowd who is doing something strange, and you want to spot that guy, even maybe not in real time, maybe after he did it, but you want to be able to spot it. And then you need to have inspection. You need to be able to look inside the traffic. And you need to have inspection at very different levels. Okay, you need to have microscopic inspection. You have to have a view from a plane. You have to have a view from a satellite, because you need to be able to get and to discover all the trends at the different levels in security. And last but most important, you have to have the right mix of skills. You have to have people with the right mix of skills. You have to have computer experts that are ready to fight, okay, and that it's not like something you can call your IT manager who is busy doing another 100 things at the time and tell him, well, we also had a security incident, deal with it. So you have to have dedicated, skilled people taking care of the security of your company. And that's it, and thank you very much. If you have questions, if we have time, if we don't, you can find me at the booth with AdaptIT.
Have some time, so questions or remarks? Or no, but I want to ask something. You discussed behavioral anomaly detection. That leads to increased number of false positives. Don't you agree with that? So if you go for behavioral analysis.
Yeah, exactly, and that's why you need these guys. Because you need
the Rambo, the other
no,
guy?
in the case of false positive, usually is the other guy. Rambo, you need it when you have a real positive. But exactly, you want to be able to detect anomalies, and then somebody with a brain has to decide, is this anomaly correct? Because maybe today I have a special offer on my website, and I see a spike in traffic, and that is an anomaly, but that is normal. Or this is an anomaly because it's an attack. So you need to have these guys to tell you. There's no magic, in my opinion, in SEC. There's no magic box that will just block everything.
No silver bullet. Okay, thank you so much.